for piecewise functions, just remember that we are evaluating, aka plugging something in, for some value of x. So this is f of x. So we're looking at the x-axis here, right? So, and what happens when x is equal to 3? That's right here. X is equal to 3. All these coordinates have an x-coordinate of 3, right? So we want to know exactly what's happening right here. And where does it intersect with the other graph? And of course, and then we can see right here, it intersects at this point, which is at 4. Okay, so f of 3 just equals 4. Nothing more than that, right? So we'll put that in and just hit next, get to the next one. Make sure everybody's caught up here. There we go. Good. All right. And try this one. Oh, I was going to say on this one, what if the question was f of 2? What's happening at x equals 2? Well, you can see we have something called discontinuity. This is called point discontinuity. So the graph seems to be seemingly going the same direction as every parabola we've ever seen does, but for some reason that the answer to it is really down here. So f of 2 would actually be equal to -3, because that's where the solid dot is. Whereas this is an open dot, which means there's no answer there. The graph temporarily stops right at 2, and the answer is here, and then it starts back up, and then it keeps on going. We'll find out when you start dividing by 0 and you have a bunch of polynomials and you divide by like x minus 2, that's when this type of thing happens in the graph. Okay. So we can have this jump discontinuity. You can have undefined as well, where there is no answer. There's a lot of different little things that we have to, make sure we go over. So same thing here, f of -2. F of -2, we go to the x-axis, because x is -2, and you can see the answer is just 2. Right, not too bad. Right, and now we have, what is f of 1? What's happened at x equals 1? You can see there is a gap there, there's a hole there, so there is no answer. This is just undefined. There's no answer there. So if there's no graph or it goes through like a hole, then that is same as having no graph for that particular value of x. Okay, so those are little things. Go ahead and try the next few together, and you'll have some that are the same. You can check each other's answers, and then you'll have several that are different from each other. So just see how that goes, and then stop when you get to, let's see here, stop when you get to 11. Yeah, to that problem. So we're going to plug in this for one or the other, not both. So you have to find out which domain does -5 belong to. Does -5 belong to this one? X is less than or equal to -1. Or does it belong to this one? X is bigger than 2. So what is -5? Is that bigger than 2 or is it less than -1? Yep, it's the top one. So that means we don't use this, right? We're only going to plug it into 1. So you have to first really start on the right-hand side of these problems by asking yourself, where does whatever value you're given, which one does it fall under, and then go to the left and plug it into that one. So this is really like step 1 over here, and then you go over here and do step 2 and plug it in. So we got, and then you have to do order of operations correctly. We had some debate first period about what the answer to this was because it was first period. Still early. So what does that equal? So does it equal -5 or does it equal 3? And some people doing an order of operations wrong before, so keep that in mind here. On here, you don't do the negatives, that's multiplication. You got to do the exponents first. So this becomes a +4, but that negative is still out there. So it's -4 minus 1, which is -5. So we still have to do all those little things correct. Okay, so we have some that are strictly greater than, strictly less than. We also have some that are just not equal. So this is saying, if x equals to 2, which one does it belong to? Does it belong to the top or the bottom? Because the bottom only belongs to if x equals 1. So if I had an f of 1, then I'd use the bottom. But this means anything else. Anything but 1. Anything but 1. That's what this means right here. X not equal to 1. Anything but 1. So we have a 2, so we don't use this one. Use the top one, so it equals 5. And you can say, well, there's no x here. Now, what am I plugging in? Like, this is an x equals 2. Where am I plugging in x here? You want to think about it as plus 0x. So the x doesn't really have effect on the answer. The answer is just 5. So no matter what value of x you put in there, it's just 5. All right. Same thing on number 13. Which one does this belong to? Top or bottom? Bottom this time, right? It says x equals negative 5, so the answer is just negative 5, and that's it. So sometimes you have to plug things in, sometimes just recognize. So try the next few there in the same manner. And then we're going to stop when we get to, let's see, I think 18. Yeah, when we get to 18, go ahead and stop there, this problem right here. To graph these, this is where the patience and everything comes in. You got to take it slow. You also have to be able to read some of this notation and know what it actually means. So recall when you have this type of situation where they have the less thans, x with less than, that means in between or between. So you're going to graph this function, just negative 5, which is a horizontal line, right? If it's just a number, that's a horizontal line. Some more. Right? And you're going to graph it between negative 5 and negative 1 only. And we also have this little subtle detail where it's less than or equal to and less than. It could be either one. And that's where we get the solid dots. That means include negative 5, right, as an answer. And we have the open ones. That means go up to negative 1, but don't actually include in the answer. So we put an open dot. So a lot of little things just to, check for. You guys have a clickable one where you just click on it, so you have to really know where we're starting. So a way of looking at this is right here. And you might have a method of, it's probably not going to be as good as this, as accurate as this. So if you choose to ignore this part and just say, I know how to do this already, you might be missing something that's actually simplify your life. What you want to do is plug in or evaluate these domain, these x's, into here and see what you get and get coordinates. So start off with just a coordinate, empty coordinate for each one, and ask yourself, well, if I plug in negative 5, what will my answer be? And if for both of them, it's just negative 5. But this way it gives you a start and stop, a very clear start and stop, as opposed to, especially on here, it could be a little more difficult. So if I plug in negative 1 and I plug in 5, I'll get the two coordinates that I start and stop at, and not worrying about y-intercepts and what the slope is and all this other stuff, and counting squares and doing all this little work that can be hard to do, especially on your screen where it's a little smaller. So if I plug in negative 1, I'll get negative 2 minus 3, that's going to be negative 5. And if I plug in 5, I'll get 10 minus 3, which is 7. So for those, I can very clearly start and stop at negative 5 down here. That's going to be a solid. And then I'm going to have an open at here. You can see how these two are the same. They don't have to start and stop at the same point. It's okay if they're not connected. And then from here to 5, 7. So I'm going to go to 5, 7, and that's going to be an open dot. And this makes it a little bit easier to do these graphs, and you're not counting a bunch of slopes and rises and runs and stuff like that. Although a lot of people try to do it first that way, they'll find that if you try this, especially when you start having 3 or 4 of these, you can't afford to be missing little mistakes because you count one square wrong, and this is a little bit easier to not make mistakes. Okay? So, and then there's just the getting used to the interface where you have to click, and you click the endpoints a couple times to make it open dots or arrows and things like that. So a little bit of learning curve there as well. All right. Let's see. Try We'll do one more together just to make sure. I'm going to be showing you the way I'm recommending it. And if you start getting frustrated and you keep getting it wrong and you're not doing this, guess what? You're making your life more difficult because you're trying for sure to know if I could do it this way, and when it doesn't work, instead of saying, let me try the other way that Mr. Hodgins saying is easier, you just keep on trying the same way that's not working. So you got to switch when you realize something's not working right. So you're going to plug in -6, right, into here, which will be +6 minus 7, which is -1. Right. And then plug in -1, which will be +1 minus 7, which is -6. And on the bottom, let's do a different color. Let's go to plug in -1. So we'll get -6. So they're gonna be connected. You can see these two are the same. Now we got 4. Plug in 4. 4 minus 5 is -1. So -1's in here. And then also mind we got a closed circle, open. These two are the same. They're open, and then the last one's open. So I have 1 closed, 2 open. So from -6 to -1, which is closed, to -1, -6, which is open. Right. And then we go to 4, -1, which is open as well. There we go. Something like that. Again, it does require some writing, but you're not making a lot of mistakes. And then when, of course, you're taking a quiz, you don't want to be, making a lot of mistakes. So write it out, watch your arithmetic, but write it out, and you'll see that just makes that much of a difference. All right, so try the next few in the same manner. So I'm going to jump to 3. That's okay. We can do that. And when they have the less than or equal to or greater than equal to's, you have to have arrows at the end. You have to have arrows at the end of it. So you have to click the dot at the end, it becomes solid. Then click the dot again, it'll become an arrow. So they go on forever. All right, so try that out for now. See how that goes. Worst comes to worst, you can always use Desmos and put in the function, and then the curly parentheses called braces, and then you put in the domain. The only thing this won't do is the open and close circles, but it'll give you the lines. Okay, so if I do mine right here, like this, just like that, you can see it'll give me the graph, but just no open and close. So at least you can double check with yours and see if something's wrong. So use your tools. Think of this like training wheels. If you're not getting them right, you don't want to get it wrong 4 or 5 times in a row. Just open this and see what the mistake is, and look at yours, look at this. Oh, I see what I did. I did this wrong. The worst thing you do is just erase it, and then you copy from Desmos, and the next problem you're no better off. You're no smarter, right? So you have to actually reflect on realizing what you did wrong so you know what to fix next time. So use Desmos as needed. It's always a great tool, as long as you use it as a tool and it's not substituting the thinking for you. The next part is when you have some nonlinear, right? So you have to do some graphing of parabolas and things like that. So let me pull it up on over here, nonlinear. The nice thing about here is that it actually gives you the different graphs, right? So we'll have a straight line for, let's say, -2. So I hit straight line, and then I drag it down to -2. You hit done, and then you adjust the domain. So you have these little arrows on either side. So -7 to 0. And you hit done. And then you can do the open and close. So these are both open. So I click once, click twice. All right, so a little bit easier for the graphing because you don't have to do quite as much work. And then you have to recognize the second part is a parabola, and that the vertex is at +2, -5. So remember, it's the opposite sign inside the parentheses. So I'm going to hit parabola, go to +2, -5, hit done, then do the domain from 0 to 5. Right, from 0 to 5, finish, and then I'll do open and close, and once again these are all open. So while they look like they're more difficult graphs, the interface makes it actually pretty good. Now, don't accidentally click this start over button. Some people think, okay, I'm done, and they click start over. You have to go down a little bit more and click submit down there at the bottom. Okay, so don't accidentally click start over unless you really mean to start over. Okay, and recall that this right here is absolute value. So when you see this right here, that's this graph. It's a V shape. So we have absolute value of x plus 3. We'll just move this up to 3. This one is a square root. So if you see square root of x, that's what this is. So we have square root of x, we have x squared, and we have absolute value of x, along with negative slope, positive slope, and no slope, constant slope. Okay, so 6 different options there, but it's all drag and drop. Okay, so go ahead and give those a try, and we got a little bit of time left. Anything you don't finish, just wrap that up over the weekend.